Okay, so today I'll be explaining you the concept of your second experiment. And you have your second experiment is which is interface a DC motor and control its direction. So here we'll be controlling the direction of the DC motor. That is, we are going to rotate the DC motor in clockwise direction as well as in the anti-clockwise direction. So that is what we are going to see in today's class. How your DC motor is going to operate and how we are going to control the turning on and off of your DC motor and rotation of your DC motor in clockwise as well as in the anti-clockwise direction. So first we'll see what is a DC motor, where do you find the applications of your DC motor. Is the presentation visible everyone? Is the presentation visible?
Yes, ma'am.
Okay, so what's a DC motor? It is nothing but it's a class of your electrical machines which is going to convert your direct electrical energy into your mechanical energy. So that's the DC motor. So DC here stands for your direct current. So it is going to convert your direct current electrical energy into your mechanical energy. So how your motor is going to rotate in how your DC motor is going to rotate. They have some sort of your internal mechanism. Either it can be electromechanical or electronics. So that is going to periodically change the direction of your current flow in the part of the motor. So they have some sort of your internal mechanism. Either that mechanism can be electromechanical or it can be purely your electronics that is going to change the direction of current flow in the part of the motor. So earlier DC motors were they were the first type that were being widely used. So since they were being powered from the existing direct current, so that's why DC motors were the first type that were being widely used. So we can even control the speed of your DC motor. So how can you control the speed of the DC motor? Either by using your variable supply voltage or by changing the strength of current in its field windings. So that's how you can control the speed of your DC motor. Either you can control it using your variable supply voltage or you can control it by changing the strength of current in its field windings. So where do you find the applications of DC motor? DC motor is used in various applications such as toys, tools, as well as in various appliances. Appliances is nothing but you have a fan. So in the fan, you will be having your DC motor. You will find stepper motor in your mixers, right? So we have one, two, and three knob in your mixers. So in mixers and all, you'll be finding your stepper motor. Fan has to rotate continuously, right? So in fan and all, you'll be having your DC motor. So that's the brief introduction about your DC motor. How can you control the speed of your DC motor? What is the internal mechanism you have in DC motor and the applications of your DC motor? So next we'll see in your LPC 1768 where your DC motor is being connected to. Where your DC motor is being connected to. In LPC 1768, so one is nothing but you'll be having two connections here. One is nothing but you have to energize the coil and the other one is nothing but the connection of your DC motor. So you can see here with the help of this relay, you'll be turning on and off your DC motor. The DC motor will be turning on or the DC motor is going to be turning off. So it depends upon this diode here. You need to energize this particular diode. So just see the connection here where this diode is being connected to. This diode in turn is going to energize your relay. So you can see it is connected to PC3. So we have to find out where is this PC3 connected to. So I'll just show you where the PC3 is connected to. This is the internal PCB structure of your DC motor. All of you just keep in mind, here itself it's been written PC3 is connected to port 0 pin number 26 of LPC1768. So where is PC3 connected to? PC3 is connected to port 0 pin number 26 of your LPC1768. So here you need to energize the relay. So the energizing of your relay depends on this particular diode. It depends on what? It depends upon the turning on and off of that particular diode. So if it is turned on, you'll be energizing this particular 5 volt, which in turn is going to control the turning on of your DC motor. So this main connection here is nothing but where is this diode that is being connected to. So the diode is connected to PC3. PC3 is connected to port 0 pin number 26. All of you just make a note of this. PC3 is connected to where? PC3 is connected to your port 0 pin number 26. This is basically, you can see you have two different connections here. This is basically used to turn your motor in clockwise as well as in the anti-clockwise direction. So that's why you have two different connections of relay here. You can see there is a diode here. So that's why we are concentrating on this particular diode. So there is a diode here, there is a diode here. So this to rotate your motor in clockwise and anti-clockwise direction, this part is going to come into picture. Okay, this is the one which is going to control the direction. You can see there is a DC motor that has been connected here. So you have 1 and 2. You have two pins in your DC motor here. So pin 1 and pin 2, which is basically going to control the direction of your DC motor, whether you want to rotate it in clockwise or whether you want to rotate it in your anti-clockwise direction. So that's why we are concentrating on this diode. So this diode is connected to port PC3. PC3 in turn is connected to port 0 pin number 26 of your LPC1768. Now you need to find out where this particular DC motor is being connected to. This DC motor is being connected to this particular jumper here, JP21 jumper. Of this jumper, it is connected to PC0. So when you check back, PC0 is connected to port 1 pin number 24. PC0 is connected to where? PC0 is connected to port 1 pin number 24. So here I have written here clearly here. Port 1 pin number 24 is basically used to turn on and off of your DC motor, and port 0 pin number 26 is basically used to rotate your motor in clockwise as well as in the anti-clockwise direction. So when you place the value as 1 on this port 1 pin number 24, it is going to turn on your DC motor. If you are going to place the value as 0, it is going to turn off your DC motor. Similarly, if you place 1 on port 0 pin number 26, it is going to rotate the DC motor in clockwise direction, and if you're going to place it as 0, it is going to rotate the motor in your anti-clockwise direction. So this is very important. This you people can make a note. Okay, this part you people can make a note. Port 1 pin number 24, if you place the value as 1 on this pin, it will turn on the DC motor. If it is 0, what it is going to do? If it is 0, it is going to turn off your DC motor. Similarly, on port 0 pin number 26, if you're placing this value as 1, it will rotate in clockwise direction. If you're going to place the value as 0, it is going to rotate in the anti-clockwise direction. Is the concept clear? Is the concept clear, everyone?
Yes, ma'am.
Yes, ma'am.
Okay, have you made a note of all those things? Have you made a note of all those things?
Yes, ma'am.
Yes, ma'am.
Okay. So that's the concept of your DC motor. So we'll see. So first and foremost, we have to set both the spins in the direction of the output. Direction is very important, whether it is an input or whether it is an output. So here both are nothing but I have to set it in the direction of the motor. I have to turn on my motor, DC motor, and I have to rotate the DC motor in clockwise as well as in the anti-clockwise direction. So the first task here is nothing but I have to set these pins in the direction of the output. Before setting it in the direction of the output, I just want to show you people how your DC motor, the internal structure of your DC motor, how your DC motor is going to rotate. So this is how your DC motor is going to rotate. This is the coil. You need to excite the coil. You need to excite the coil, and then the motor is going to rotate. I said you will be having some electromechanical system, so which is going to attract. You will be having your magnets here, your north as well as your south pole. You need to attract that, and the DC motor is going to rotate. So this is how your motor is going to rotate. Got the concept? And this you have to energize the coil. So when you are going to energize the coil, what is going to happen? Your motor will start rotating. You will be having the north as well as the south pole. So you know it will attract and it will start rotating. And the concept of your relay. So that's why we have to energize your relay. So this is initially it will be off. You need to turn on. What will happen? Your DC motor will start rotating. It will be having a coil which is going to energize the coil and it will start rotating. This is what I showed you there. Poles. You'll be having your north as well as your south pole. So that is going to energize the coil and your DC motor is going to rotate. So that's the working of the relay. The relay what you had in the diagram. So that's the working of what? That's the working of the relay. You need to turn on, which in turn is going to energize the coil and your DC motor is going to rotate. Clear everyone? Is it clear? Is it clear?
Yes, ma'am.
Why one person is responding? Understood everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay, I'll show you the algorithm, then we'll go for the working of your DC motor. So these are the steps what you people have. This is the algorithm. So what you people need to do, you need to configure your pins, port 0 pin number 26 as well as your port 1 pin number 24 as your general purpose input output pins. Then you need to configure them as your output pins. Then we have two steps here. First you have to rotate your DC motor in clockwise direction and then you have to rotate your DC motor in the anti-clockwise direction. So what are the steps to rotate your DC motor in clockwise direction? First, initially if the motor is running, first task is nothing but you need to turn off the DC motor. Okay, so give some delay, turn on the coil, then turn on your DC motor. So turn on the coil is nothing but you need to excite the coil. So you need to turn on the coil, then you need to turn on the DC motor. DC motor is connected to port 1 pin number 24. Here your DC motor is being connected to. Then introduce some delay. You'll be seeing the motor rotating in clockwise direction continuously. Then to rotate the DC motor in anti-clockwise direction, we had seen on port 0 pin number 26, if you place the value as 1, the motor is going to rotate in clockwise direction. Then you have to place the value as 0 to rotate it in the anti-clockwise direction. So that is what we are doing here. The motor is already running here. Again, first task, turn off your DC motor, give some delay, turn off the coil. Why we are turning off the coil? Now we have to rotate the motor in anti-clockwise direction. So the value on port 0 pin number 26 should become 0. So then turn on your DC motor. Everywhere we need to introduce the delay, because if you don't introduce the delay, you cannot find out whether the motor is running or not. So for the motor to run continuously, we have to see from the eyes, we need to introduce the delay. Otherwise, we cannot find out in which direction your motor is running, whether it is running in clockwise direction or whether it is running in your anti-clockwise direction. So that's the algorithm of your DC motor. So here also we have written here the port 0 pin number 26, which is your direction control pin, and it is going to function as your GPIO in the direction of the output. And port 1 pin number 24, this is where you'll be connecting your DC motor onto the kit. On the kit, you need to connect your DC motor. So the DC motor is connected to port 1 pin number 24. Again, this port 1 pin number 24 is going to function as your GPIO, and this also we have to set it in the direction of the motor, in the direction of the output. Here we need to rotate your motor, and we need to rotate the motor in clockwise as well as in the anti-clockwise direction. So these are the steps on the same lines the program is being written. See here, turning off is nothing but we have two registers here. We have already seen the various registers of your LPC 1768. So which are the various registers we have seen? We have seen FIO mask, FIO pin select, FIO set, and FIO clear. If you want to turn off, don't go and place the value as 0 on port 0 pin number 26. You have to just give the instruction as FIO clear. If FIO set means it will turn on your DC motor, FIO clear means it will turn off your DC motor. So you have to always make use of these instructions. You have to make use of FIO set if you want to turn on, and you have to make use of FIO clear to turn off your rotation, setting and clearing. Okay. So now again I want you all to write in your books from bit 0 to 31, such that when I give the instructions you can place the value and say me the equivalent hexadecimal value. So all of you, twice you people write bits from 0 to 31. Twice you people have to write it bits 0 to 31, because we need to configure port 0 pin number 26, and we need to configure port 1 pin number 24. So I want you all to write it twice in your notebook. From bit 0 to where? From bit 0 to your 31. Can you all see the board? Can you all see the board?
Yes, ma'am.
Okay. Have you all returned it? Bits from bits 0 to 31. Because your ARM is nothing but it's a 32-bit microcontroller. It's a 32-bit microcontroller. Have you all returned?
Yes, ma'am.
Yes, ma'am.
Okay. Now I'll start with the explanation. According to that, you people can place the value. First, I need to configure your DC mode port 0 pin number 26 in the direction of your output. Okay, I need to configure what? I need to configure your port 0 pin number 26 in the direction of your output. So go to pin number 26 and place the value as 1. So we know that if you give the value as 0, if you give the value as 1, it will set in the direction of output. If you give the value as 0, it will set in the direction of the input. Now here I am checking the output here. So I have to set it in the direction of the output. So go to port 0 pin number 26 Go to port 0 pin number 26 and place the value as 1 over there. So what is the value I need to place? I need to place the value as what? I need to place the value as 1 on your pin number 26. So what is the equivalent value I'm going to generate? This is 0, 0, 0, which is 0, 0, 1, 0, 0. What is 0, 1, 0, 0?
4.
4. 0, 1, 0, 0 is 4. This is all zeros. This is 0. This is 0. Rest all pin values will become what? Rest all pin values will be 0 because we are not configuring any other pins. So what is the equivalent value I'll be generating here? What is the equivalent value I'm going to generate here? So I'll be generating 0x 04 0400, then all four zeros 0000. So please make a note of this 0x 04 followed by your 6 zeros. 0x 04 followed by your 6 zeros. Note it down, everyone.
Yes, ma'am.
Okay. So now I want you all to see me since I'm making use of port 0 pin number 26. So it comes under which pin select? It comes, I have to make use of which pin select?
Pin select
I'm
3, ma'am.
making use of port 0 pin number 26. So which pin
Pin
select I have
select
to make
1.
use of?
Pin select 1, ma'am.
Very good. Why pin select 1?
16 to 32.
Yeah, since I'm making use
31.
of port 0 pin number 20, very good, correct answer. Since I'm making use of port 0 pin number 26, we all know that for port 0, pin numbers from 0 to 15 will be in pin select 0 and pin numbers 16 to 31 will be in pin select 1. So like this, you all write one table. This is for port 0. Similarly, people can write it for port 1. For port 1, pin numbers 0 to 15 will be in, since already it is pin select 0 and pin select 1. So you can write it here as pin select 2. And pin number 16 to 31 will be in pin select 3. So like this, if people just make a note. So for port 2, port 3 as well as for your port 4. You have 5 ports in your uh, ARM Cortex M3. So like this, if you people keep it ready, it will be easy for you people to find out which appropriate pin select I have to make use of. Can you say me for which pin select I have to make use of? Since I'm making use of port 0 pin number 26, it comes under this configuration. I have to make use of which pin select? I have to make use of your pin select 1. For this 0x 04000, I need to make use of pin select 1. So I'll have to make use of which pin select? I have to make use of your pin select 1. On the similar lines, now I have connected my DC motor onto the kit. It is connected to port 1 pin number 24. So I have to configure this DC motor in the direction of the output. So please go to pin number 24 and configure it as 1. Rest all bit values will be 1. Rest all bit values will be 0. Rest all bit values will be 0. Rest all bit values will be 0. So come on, Semi, what is the address you'll be generating? What is the address you'll be generating? What is the value you'll be generating here? I have to configure the DC motor in the direction of the output. So your DC motor is connected to port 1 pin number 24. So go to pin number 24 and place the value as 1. Go to pin number 24 and place the value as 1 and rest all bit values as 0. So what is the equivalent value I'm generating here?
0160, ma'am.
0, 1. What is 001? 001 is nothing but 1. 0x 01 0 0 0. So this I'm making use of port 1 pin number 24. So port 1 pin number 24, which pin select I have to make use of? Which pin
3.
select I have to make use of? Very good. I have to make use of pin select 3. So keep this in your book. I have to make use of pin select 3. For this 0x04000, you have to make use of pin select 1, and for 0x01000, you have to make use of your pin select 3. Only these two values you'll be requiring in the DC motor. I hope you all have noted down.
Yes, ma'am.
Have you all noted down?
Yes, ma'am.
Okay. Now I'll be sharing the program. I'll be explaining the program now. So this was the logic which all you people require for your DC motor. Still very less people have joined. Not everybody has not joined. Okay. Can you all see the program?
Yes, ma'am.
Okay, fine. See, we have to rotate your DC motor in your clockwise direction as well as your anti-clockwise direction. So that's why we give it as void, clockwise, void. It will return back the function normally. So that's why inside we give it as void function. So we have unsigned long I. We'll be making use of some integer here, which is nothing but unsigned long I. Then you'll be having int main void where we are going to configure this pins. So since we are selecting these pins here, initially we keep all the pins values as 0. LPC underscore pin configuration pin select 1 PINCON stands for your pin configuration. So initially we'll clear all the bits, okay, of port 0 pin number 26. I have already said you why it is pin select 1. You all have noted down in your book also. Since we are making use of port 0 pin number 26, this port 0 pin number 26 comes under your pin select 1. So I'll be clearing all the bits over here. On the similar lines, I'll be clearing all the pin values of your port 1. LPC underscore pin configuration pin select 3 0x000. First, I'm going to clear all your pin values over there. Pin values of those bits. Okay, next I have to set it in the direction of the output. Both port 0 pin number 26 as well as your port 1 pin number 24. So that's why I'll be giving it here as LPC underscore GPIO. Why it is O? Because it is port 0. So that's why you'll be writing it as O here. I have to set both the pins in the direction of the output. FIODIR, or this is the symbol for or, which is equal to 0x04000. So we have seen how we have got this value as 04. Then we have to set this DC motor in the direction of the output. So since it is connected to port 1, I'll be making use of GPIO 1 here. That's why you have 0 and 1 here. Since you're making use of port 0, it is 0. If you're making use of port 1, you'll be writing it as GPIO1. Again, you need to set it in the direction of the output. So you'll be giving it as 0x01000. So already I've taught you how we have got those values as 1 and 4. Now this is for introducing your delay, because we have to rotate your motor in the clockwise as well as in the anti-clockwise direction. So while it is true, you'll be giving clockwise, so it will come here, void clock underscore voice void. So first, as I said you initially, we have to follow it. Keep these three things in your mind. First, turn off the motor, introduce the delay, turn on the coil, turn on the DC motor. This is for the clockwise direction. So you know that your DC motor is connected to port 1 pin number 24. So you have to turn off your DC motor. So as I said, don't place the value as 0 here. So that setting and clearing, you have the registers here. So give it as LPC underscore GPIO1 FIO clear. It will clear. That means it will turn off your DC motor. Then introduce some delay. Then set it to rotate the motor in the clockwise direction. This is port 0 pin number 26. On port 0 pin number 26, we have placed the value as 1. So that's why we have got it as 0x04000. So I have to rotate the motor in clockwise direction. So first I'm setting it to rotate it in the clockwise direction, and then I'm rotating the turning on the DC motor. This is for to rotate the motor in clockwise direction. I'm setting it to rotate the motor in clockwise direction, and then I'm turning on the DC motor. So you'll be having the delay. After some delay, it'll come back here to rotate the motor in your anti-clockwise direction. So again, for the anti-clockwise direction, what can be the small change I have to do here? The first step is common. The first step is nothing but I need to turn off the DC motor. I need to turn on the coil. For rotation of your DC motor in clockwise direction, what is the value I have to give here? What I have to give here? Can someone say me what are the small changes you need to make to rotate your DC motor in anti-clockwise direction? Can someone say me? Can someone say me what is a small
Zero
change?
one should be, ma'am.
What, Shabnam?
We'll give 01 here, ma'am.
Where do you give 0, 1? Where do you give, Shabnam?
When coil is on, ma'am.
See, for anti-clockwise, I said you the value on port 0 pin number 26 should be 0. What is one small change you people have to do here? Only one small change you have to do in the program. There's a
Set the
value.
value.
Yes, Sania?
Set the value.
No, I'm repeating once again. Support 0 pin number 26. If you place the value as 1, it will rotate the motor in clockwise direction. Now I want to rotate the motor in anti-clockwise direction. So the value on port 0 pin number 26 should be 0 in order for the motor to rotate in anti-clockwise direction. So what is the small change I need to make it here to rotate the motor in anti-clockwise direction? What is the small change I have to make? What is some small change? I have given you even the hint also. I have given even you the hint also. Only this line needs a modification. What is that modification you have to do here?
Clear the value, ma'am.
Very good. Very good side. See here, I have said, I have kept on repeating to you people, right? So you give first for both clockwise and anti-clockwise, the same instruction you have to follow. First, if the motor is running, first you need to turn off the motor. How you'll turn off the motor? You have to give it as clear. Then introduce some delay. Then set the motor to rotate in your clockwise direction. Then turn on the motor. Turn on the motor. Now what I said you for anti-clockwise direction, the coil should rotate in anti-clockwise direction. So the value on port 0 pin number 26 should be 0. So instead of placing it as 0, what is one small change I have to do here? Instead of that, I have to give it as FIO clear here. I have to give it as what? FIO clear. Clear means it is just going to clear that value. Instead of 4, it is going to become 0, and your motor is going to rotate in which direction? Your motor will start rotating in your anti-clockwise direction. So if you just remember this set of your program for anti-clockwise, this is a small change you have to give here. FIO clear here you have to give. Here instead of set, you have to give it as what? You need to give it as FIO clear. So that's the part you have for the anti-clockwise direction. So you all can see here. Turn off your DC motor, Then you need to rotate your coil in anti-clockwise direction. So turn off your coil, then rotate your motor. The motor starts rotating in which direction? The motor starts rotating in your anti-clockwise direction. Only this change you people need to make it. So you have to give it as clear. So you people have to just remember two things here. Port 0 pin number 26, that is basically used to control the direction of your DC motor. If the value is 1, the motor is going to rotate in clockwise direction. If the value is 0, the motor is going to rotate in anti-clockwise direction. So for clockwise, set it. For anti-clockwise, just clear it. So that's the part of your program. That's the algorithm. I had explained you the algorithm first. If the motor is running, turn off the motor, introduce some delay. Then what you're going to do? Rotate, turn on the coil, turn on the motor. So for anti-clockwise, just change it for clear. FIO clear. That's all is the program of your DC motor. That's all you people have to remember. Clear all the pins, configure in the direction of the output, then write the subroutine. Clockwise, it will go here. For anti-clockwise, it is going to go here. After some delay, it will go to your anti-clockwise. Any doubts?
No, ma'am.
Any doubts, anyone?